Good evening and welcome to the BS and Beer Show. BS stands for Building Science. We've been doing this for a year now, so hopefully this isn't your first show, but if it is, welcome. Tonight's topic is, do sheet goods make good air barriers or sheet goods as air barriers? So we're going to have a hopefully lively discussion on that one tonight. I'm Emily Mottram here in Maine, architect. I told Travis earlier we had to go away last week and I wasn't home, so there's no beer in my house, so it's wine tonight, the nice petite Shiraz, so I can join you all. BS and Beer is an independent grassroots movement, so everybody who shows up on the show is volunteering their time, so they say thank you to our guests if you have the opportunity. It's started as a local meetup group and now it's become a Zoom show. But we do want to thank Green Building Advisor and Fine Home Building for helping us to make this happen on this platform and for posting the replays for all of our past shows, both on Green Building Advisor and on our YouTube channel. So, Mike, if you want to give some general announcements.
I will. Thank you, Emily. I'm Mike Maines. Tonight I am drinking it's called Curious Elixir. Number 9, Curious Elixirs makes these really tasty non-alcoholic cocktails. This one tastes a lot like a Negroni. And I was just looking up what a Negroni is, so I could tell you that, but I don't know. But anyway, it tastes good. Announcements are to participate in the chat box. If you haven't done it before, at the bottom of the screen is a green button, or there's a button anyway. This says chat. Click that and be sure to click all panelists and attendees or possibly everyone or something, because it defaults to panelists only, so we can see what you're saying, but nobody else can. Every week, Fine Home Building sends out Zoom reminders. If you want to receive those as well as other information about the show, join our mailing list at thebsandbeershow.com or check out the weekly post at Green Building Advisor, which goes up every Sunday morning. The video recording of tonight's show will be available at Green Building Advisor, and all past shows can be found there or on YouTube through a link at thebsandbeershow.com. An audio-only version of the BS and Beer Show is available on Spotify and Apple Podcasts. And we will put in the chat box a couple of events coming right up is FIASCon. So FIAS, the Passive House Institute US, is the leading passive building conference for climate-specific zero energy design, construction, and building science expertise, scheduled for October 12th through 15th in Tarrytown, New York. And then very exciting, coming up in February, the NAHB's International Builders Show, February 8th through 10th in Orlando. We will be there, the Brew Crew, to host live BS and Beer shows in the afternoon, all 3 days. So a very exciting thing that Ben Bogie set up for us. And I will turn it, woohoo. We are still waiting on Chris Corson, but we will turn it over to Travis to introduce our surprise guest.
Yeah, I'm excited. So I just got to spend a couple days in Kansas City with Jake, and now we have Jake on the BS and Beer Show. So, of course, most folks are familiar with Jake Bruton. He's a performance builder, a high performance builder in the Columbia, Missouri market and surrounding states as needed. He's a good guy, a generous person, a father, a frequent contributor to the Unbuild It podcast and the Build Show Network. I don't know. He's a good guy. What are you drinking, Jake? Welcome to the show. Thanks for doing this.
Wait, you forgot. He's an adequate friend.
I don't think he defines me that way.
Oh, man.
It's more insulting.
All in due time.
With deliberate, focused, hard work, I might be promoted to adequate friend. I just realized this is like night 4 of drinking and talking about building and building science in a row since I was in Kansas City Monday, Tuesday, Wednesday. I am drinking from my Retrotech can koozie, Urban Chestnut Zwickel. It is a St. Louis brewery, and it's a Bavarian style lager. It's a good, like, after work if you can't bring yourself to just have a Bud Light.
That's
I like
Urban
your can koozie.
beer.
I'm jealous.
Well, next time I'm going to see you, I'll bring you some because Travis gave me like 200 of these last year that they were left over from the symposium last year. Or somebody did.
I need a blower door koozie. That I didn't know that was a thing.
We can make that happen.
Yeah. Well,
So
let's just move ahead. We're here to talk about air barriers. We all know a little bit about air barriers. I think we can just move right along. Would Jake, any chance you'd want to sort of help us set a baseline? Any chance you'd want to give us a few ideas of what an air barrier is, why it is or isn't important,
Sure.
etc.?
So when we're talking about air barriers only work if they are continuous, if they surround the entire envelope. If you are familiar with Stephen Basic, architect that we work a lot with, that's also co-host of the Unbuild It podcast, he has a great house in section with a red line going around it to represent Steve Rick's red line test. So if you're looking at your plans in section and you try to trace that air barrier, if you have to pick up your pen or your pencil, then you're going to have to pick up the caulking gun or the nail gun or whatever it is, or the tape roller, and it won't be continuous. So the idea of an air barrier is to reduce let's say that the transmission of air from outside to inside or inside to outside on any building envelope. Meaning, if we can keep that air inside the house, we've already invested in it from a financial standpoint because we've filtered and conditioned it, or hopefully we've filtered and conditioned it. If you live in Hawaii, maybe it doesn't matter as much. And we don't want that air to leak, because if it leaks, then we have to bring air that hasn't had that investment into it, and we have that investment a second time. So one of the ways that Passive House succeeds in making homes energy efficient, they claim 80 to 90% more efficient on the heating and cooling front, is simply by keeping that air inside the house. And I would argue that that's probably the biggest way that they succeed by making that claim, is by actually keeping that air inside the house. Lawrence Berkeley Labs did a study in 2012 that if all 130 million houses inside the United States were instantly below 1 ACH 50, which is 1 air change per hour at 50 pascals of pressure, that we would save $22 billion on heating and cooling costs.
Whoa.
So your air barrier is important. And I would note that my house qualifies for Passive House levels of energy efficiency, meaning my electric bill last month was $143, and it takes care of hot water, cooking, and all of our conditioning. And my house is way larger than anybody should have a house. So,
in subject to that,
a brag,
put more.
he has a big office.
He has a what? A big
He has
office.
a very big office.
yeah, we have a normal size house that we attached a huge office to, and my project manager and I still share a desk, even though and this is our Unbuild It podcast studios as well. So we have plenty of room to have people come and work in our office. In other words, we have 1,200 square feet worth of office for the two of us.
That's awesome. I was going to say, in retrospect, my house has an 8.5 ACH built in the 70s, and I just put a couple more holes in it today. But you got to put more holes in before you can, cut more holes out.
Are these on purpose holes?
Yes. We actually installed an ERV today to help with, even though my air infiltration rate is high, what we're doing is patching holes in the ceiling. So, and everywhere else. So we had to cut into some chases that, no surprise, there was nothing in the attic at the top of the wide open chase. And so, technically there's a hole in the wall to the wide open chase, but it's got to get worse before it gets better, right?
Exactly. Do you mind me asking what unit you're installing?
We're installing a Brone. I think it's a 240 TE, but I got to look at it, and it's got auto balancing and stuff.
Is it the double bath fan size? Yep.
Yes. So the layout of our house doesn't make it possible for us to have bath vents in our 2 bathrooms. So it was definitely a good upgrade, but also healthy ventilation is really important. And the fact that our house is from the 70s and that 8.5 ACH is probably coming from my attic. I'd like to clean up the air a little bit there. But I also teach a building science class, and I teach it right before BSN-BR. And today we did longhand heat loss calculations on air transported heat loss. So that was great.
So now you're more motivated to have this conversation.
Yeah, 22 million or 22 billion or whatever you just said. I mean, we went through today and just said, how would it differ if you went from what's required from code to trying to meet passive house? Like, oh, hey, look at that. And, just not taking into account any of the weather related activities or stuff, just longhand air leakage. So,
yep. Well, and it's actually the ERV conversations are a really good conversation to have with air barriers, because if you have control over what's inside the house, you can filter it, you can temper it, you can really manage for health and comfort by simply keeping outside air outside.
Yeah. And I know you do this, so I'm really hoping that you'll talk about it, since tonight's episode is really on sheet goods. But as I'm disassembling my 1970s house, I really wish they would have put the sheetrock up first and then put the interior walls up, because not a single one of my interior walls or the exterior sheetrock is connected to the wall sheetrock.
Mm-hmm.
And so part of the reason why I have an 8.5 ACH is due to every single one of those seams. So I know we're going to talk about it, and hopefully when Chris joins us, we'll talk about, exterior OSB and whatever. But since we're talking about sheet goods as air barriers, are you pro air barrier membrane, or the sheetrock does good if you do it right?
I'm very much believe in what Myron Ferguson writes. I haven't practiced it really, but I do know that we can do this with just sheetrock. It is possible, because the majority of the last 6 houses that we've built, Steve knows I'm on the podcast right now and he's choosing to call. He chose to call yesterday while I was presenting on purpose too. He's got a nice little sense of humor today. Now I lost my train of thought. Oh, I know that drywall as an air barrier can work because we're using it on our ceilings of our houses now. And we're building, the last 6 houses that we built are all between like 0.58 ACH 50, which is just barely below passive house, all the way down to like 0.33 ACH 50. And that is drywall as, whatever that would be, 20% of the air barrier or something like that. So we know that works. We know that panel goods with the seams detailed can work, right? And as Emily said, the idea that we're going to monolithically cover our ceiling and fire tape it and then build interior partitions, that's like the key, because that's the continuous thing. And you just described non-continuous. So if you drew that in section, it would be the drywall comes to the top plate and it stops, and then it starts on the other side of the top plate, right? And then they cut a return air in, they cut a duct in, and then they drilled 4 wires or a big hole for a vent pipe that was half the size of the vent pipe, like all those things. That's why it works, is because it's attention to detail.
Yeah. So it's always been this question is like, what's the easiest way for standard construction to do that? Is it with the sheetrock, or is it with your exterior zip system, OSB, lapping the top of your wall system, going across the ceiling? It's like, how do you make it continuous when your sheet good is a solid material?
Yeah.
Sheetrock was a great example.
I mean, if we take this conversation to what I think of as the lowest common denominator, like the guys building 3,000 houses a year, they're not gonna rock the ceiling and then come back and do interior partitions. Their framers aren't gonna return for a second trip. They're just not. Even if the builder thinks it's important. So at that point, I honestly figure that in the production market, it's aero barrier or a product like it that's going to seal things up for them after the fact. But I don't see that as a real solution for everybody else, just because there are easy ways to get there. Don't get me wrong, I love aero barrier and it works, but we're doing houses below Passive House with carpenters that we've trained, not people that have been to some crazy Passive House training in Europe to figure out how to detail an air barrier. And we're doing it with stuff from the regular lumberyard, from where we normally buy stuff. We're doing it with zip sheathing and tape and liquid flash and acoustical sealant and drywall. And I don't think it gets any easier than that, really.
Jake, what do you do about ceiling penetrations? Lights, bath fans, ERVs, etc.
You're not allowed to have lights.
No lights. Okay, got it.
Hey, that's my line. You really can't have lights in my thermal envelope.
No, so a lot of our lights, if they're surface mounted light fixtures, we're mounting them to what you would think of as a pancake style box, like a ceiling mounted 7/16 tall or 9/16 tall box that has been screwed to a piece of solid blocking over top of the drywall, and then acoustical sealant around the box, and then the wires coming through, and we're foaming the wires. So we've cut a hole in our air barrier, but then we've glued to the top side of it, and we've foamed the things that were coming through it. And then when we are working on things like, recess lights or bath fans or anything else of any vertical size, we just build a zip box on the top side, nail it to the trusses, and then caulk it to the top side of the air barrier. And we really have had great success with it. And we always have, on our most recent houses, because we're working with European windows, we have huge cutout scraps of our zip or zip R. And it's been like, we haven't really had to buy any extra. I mean, we are paying for a lot more tape because we're making these zip boxes that are, a 5-sided box that then gets caulked to the top side of the drywall. But even working with acoustical sealant, we can go in the day before, do the on everything, and then let the rockers push it up the next day, and we're not like fighting them for space. So it is way more pre-planning. We're not moving things. We're not moving things after they're poked through there.
Right.
So
does anybody
go ahead, Mike.
Or just, I'm wondering, or we're throwing around ACH numbers. That's, ACH 50 air changes per hour at 50 pascals. Does anybody know why that's the standard, and what do you think about ACH numbers versus shell leakage numbers?
I heard a really intelligent speaker just a couple of days ago point out that the ACH 50 number was somewhat arbitrary. It was chosen because it was a level of leakage that could be tested without damaging the house. I believe that's accurate. Am I quoting you accurately, Jake?
Yes, you're quoting me accurate. Thank you. And I was told that the first time that Building Science Corp tried to do a blower door test, they had decided that they were going to pressurize the house to 100 pascals of pressure. Because if you know Joe math, 100 is a good round figure that we can work with, and they couldn't, so they just went, let's do 50. Which is commercial like, if you really do understand where like 30% of the code book comes from, it's that kind of conversation. Some of it's like real solid engineering stuff, and some of it's like, somebody wrote a paper saying we did it at this, so we're doing that.
Yeah, I think there was a bunch of testing too. And what I learned back when I did a bunch of my certifications from the blower door manufacturers is like 50 was the most reliable number, right? So like even now with our HERS ratings, we have to do it 50, 40, 30, 20 and have, like a across the board, whatever. But 50 was like the most reliable number that they could use that consistently had a similar. Sense. But again, those ACH leakage and the blower door and how you do it and how it's converted with the software or whatever is really impacted by how windy it is. I mean, anybody who's done any blower door testing has probably tried them all. You put the tube outside in a bottle, you put it in a tennis ball, you put it in the bushes, you've done, and those numbers fluctuate.
Do the crawl of shame back through the door so that you can put the hose out there that you forgot to put out there. Yeah.
Yes. And you joke about that every time that you remember to do it. And you're like, I've climbed through this before.
So you actually bring a really good point, Emily. It is not an accurate device. There are too many variables. How long has it been since the device was calibrated? who is running it? How trained are they at operating this thing? What are the conditions like outside? Is it 72 inside and 72 outside with no wind? Yeah, our results will be pretty darn good then, probably, because the computer's not making a whole bunch of calculations to calculate the baseline to try to figure out what we really should be getting, things like that. And then how well do you install the door? And how well do you calculate the volume of the house? Because so for us, I calculate the volume of the house as the inside face of the sheathing. And I don't calculate for studs. I don't calculate for insulation eventually. Because we're using so many different like air permeable insulations, I just leave the number the same all the way through our process. So when I test the first time, and we're just testing our envelope without any windows cut out, the second time we're putting in windows, the third time we have in drywall, technically my volume did move a little bit. But what I decided a long time ago is that I was going to do that calculation once. I was going to do it the same for every house, and that's the only way it was going to be. That way my numbers would reflect against each other. So I'm not changing my methods. And I can't think of the book that describes it. It's referenced in the code book. They don't talk about it. They just say interior volume.
That's great.
How do we do that?
It's a great question, because it involves air barriers too, because, as an architect, I have access to my software and I can get pretty specific about what my volume is. But if I'm going to make my air barrier the exterior sheathing, do I choose to do my volume from what I'm determining is my air barrier? Even though if I did a great job with my sheetrock, I might actually have 2 air barriers, or I might, so in the energy world, and when you're doing modeling and software and blower door testing, it's all a little bit of a, kind of interesting factor too, is, I always do it basement door open, basement door closed, but my basement door is part of my thermal barrier. So realistically speaking, the basement door should always be open when you're looking for that number, because it is directly, like, there's so many fun factors, we'll call them.
And then and even just who installed the door. So I've decided that all my tests are run I run my test the same way that our HERS rater runs it, because we have to get our final numbers from them, but our preliminaries come from us. So I don't tape our blower door in place, which I could and get better numbers. And I don't put a bungee cord around the fan, which when Mike Gurton told me that the way he stops leakage around the fan is with a bungee cord, I was like, that is the most Mike Gurton thing in the history of the world, is that he solves a problem, like a big problem in science for him, by using a bungee cord. And I did it on one of our projects, and it went from 0.33 to 0.3. And I was like, oh, that's a big difference.
As I mute myself and say, but what I want to know too is, like, how much different is my blower door from, depending on what you're doing? Like, some of those passive house doors that are massive, close on the seals, whatever, like my blower door, it probably is way worse than that door,
Mm-hmm.
So none of it's ever going to be a super accurate, I mean, you can get close, and I guess we're splitting hairs probably at that point. If you're trying to get a passive house certification, you have to do these things. If you're trying to build a pretty good house, then you want to know roughly where you're at. And the blower door test at 50 pascals is a 20-mile-an-hour wind on all 4 sides of your house. Does the wind ever blow 20 miles an hour consistently on all 4 sides of your house? Like, no, that's not an accurate portrayal.
Isn't it all 6? Like, aren't we talking about wind from under the slab and from over the roof as well?
Yeah.
So,
true.
So we're really, as someone who is trying to get more and more high performance clients, people that are interested in this, I am certainly calculating that maximum volume of interior space from the furthest out air barrier that I can, so that I can brag about my excellent number to my next potential client. Like, yeah, with our efforts, we were able to get this giant house down to this leakage number, or this small house. If I'm building a small house, then I can really brag about it. And then I can explain how much harder it is to get that lower number on that small house. And just to put a pin in the Mike Gurton thing, I'm really surprised that it was a manufactured bungee cord and not a piece of lumber strapping with a stick wrapped in it that he used like a turnbuckle to then, like you would tighten a fence post. I really think that would be more Mike Gurton. That guy is so resourceful, the ultimate MacGyver. Anyway.
Yes. Yeah.
But it is,
MacGyver Gurton.
It is not an accurate tool. And that's why Passive House says 0.6, because anything below 0.6 means you're doing good.
Yeah. Or it's also that's what International Passive House says is volume, and it sort of penalizes smaller buildings, and so so that's where FIAS and some people say it's better to test per square footage of wall area. I can see the reasoning for that too. It basically takes it sort of points directly at craftsmanship and nothing else. But is that good, better, worse? Does it even have an effect on, like, is it relevant, you think?
I mean, I think all of these measurements can possibly be relevant as long as everyone is doing all of these the same way. Hi, Mike. I just saw that Mike said he came in. Already somebody's mentioning his name.
I just told him we can promote him so he can defend himself if he feels that it's necessary. But somebody did ask a question in the chat box.
You should. We didn't get a good chance to talk yesterday. We didn't
have enough beers together. We need some more. We need some more Mike Curtin. But someone did ask something in relationship to that, which we can all kind of talk about. Is it a problem to have more than one air barrier?
I mean, I certainly think it could be, but I don't think it's necessarily a bad thing. How about that? The building science answer. It depends.
It depends.
What is your air barrier made of? So on my homes, the general assembly that we're using, if we're using zip sheeting on the outside and drywall on the ceiling that's properly detailed, then everywhere I don't have an outlet on my walls is technically still an air barrier. That's not hurting me at all. It's vapor open. It's just not promoting air movement.
I think that's a great question too, because you use a lot of zip system, which is not vapor open, which might be a good air barrier. So you have an internal air barrier, which is maybe helping your vapor transfusion. But if you say, you know what, our zip system and our exterior is the way that we're going to get some of these production builders to get onto it. What does happen if you have, zip system, like my understanding about OSB is that the glue in the OSB is more vapor, less vapor permeable than the exterior sheathing. And so is it a problem if that is your air barrier and you don't have, like, in that case, I could see where having two air barriers might really be in your favor, because the first one is hopefully cutting down some infiltration.
Well, so maybe if you have a good air barrier on the outside. No, seriously, like if I have the last house that we tested in just frame without the windows cut out with zip and drywall on the lid was 0.30, half of Passive House. What driving force is challenging the interior drywall on my walls at that point? There's no air moving through that. That's like a hole this size over the entire envelope of a 3,000 square foot house. This is not a driving force, at which point maybe we're saying that the drywall on the interior face is no longer acting as an air barrier because there is no air trying to move across it.
That's the key in my mind to the multiple air barriers argument. If you have one actual air barrier, then the air has already stopped moving. So having the additional air barrier, if there's no pressure difference, it can be stone, it can be open. It doesn't matter. It's superfluous.
But or except if you're using the exterior sheathing as the air barrier and you have an air permeable insulation, the indoor air, depending on how well sealed the interior is, that interior air can circulate through the fluffy insulation and get to the sheathing. And so you could end up with a dew point problem, which is why the code has certain requirements for vapor retarders. So the vapor retarder is sort of, I think a vapor retarder is assumed to also be a reasonably good air barrier. But
stop living where it's cold, Mike.
Yeah. I was going to say, this is where we're going to get in trouble because I asked Jake a question that's not a problem where he lives.
Right. Yeah, it's always nice outside. What's the problem?
Problem solved.
Yeah, there you go. All right.
Move to nice places. That's it. I think in the wall assembly challenge that we did with Travis, I thought that was really applicable. If you want to build things that don't have to be quite as complicated, live somewhere where there isn't quite so much weather.
There you go.
And make the design not as complicated.
Yeah.
Or well, this whole discussion sort of came about, or tonight's topic came about because of a Green Building Advisor post about a study that was basically saying commodity OSB doesn't make a good exterior, doesn't make a good air barrier, and it's pretty contentious. We've had some arguments on GBA, we've had some arguments on Instagram. My own experience is when I worked with Chris Corson, we had a project where we're using commodity OSB as our air control layer, and we were routinely testing around 0.4 ACH50. Just we had it's factory built panelized passive houses and pretty well dialed in, but we did a project where we just couldn't get below 1 ACH50, which 1 ACH50 is great, but when we were shooting for a maximum of 0.4 and just all of our usual tricks didn't work, like what's going on, and it happened to be about the same time the news was starting to hit that some OSB was not really airtight. So we did the taping the plastic over the sheets and running the blower doors and found that yes, the commodity OSB we were using was permeable. Michael Anshell argued on Instagram that if it meets the definition of an air barrier, then it's an air barrier. It doesn't matter if you can meet your passive house numbers. And so
it could be a poor air barrier.
Yeah. Well, and which reminds me of you guys probably know how the air barrier definition came about. It's another Joe Stebrick story. Basically, they had to define an air barrier, and so they tested. And so he looked at a piece of sheetrock and said, "That seems like it would be a good air barrier." And they tested it, and that is the definition of an air barrier. It's 0.02 liters per second per meter squared at a pressure differential of 75 pascals when tested in accordance with ASTM E2178. But it's literally a piece of drywall is the definition of an air barrier because that's what they tested to define an air barrier. But,
well, and we forget that like all those ASTM tests have a story similar to that. Somebody decided that that's the way it was going to be. It's just Joe's the one that shares we just thought that up. We just decided. So it's funny that this article is what we're going to talk about, because I was when Travis asked for me to be on the show, I said, well, when I bought my first blower door in 2013, I wanted to figure out what a hole meant in my air barrier. Like I was trying to connect CFM to certain diameter holes and things like that. And I had just started using Zip, but Zip was expensive. So I built a box for my blower door out of commodity OSB. I think I paid $6 a sheet for it at that point. Because I was trying to get zip tape to stick to it, I did flip it around the other way. So if it is a one-way air barrier, I put the rough side inward into the box and the smooth side out, which would be the opposite way it was on a wall, so that I could zip tape it together still. And then I ran the fan at 50 pascals and drilled little holes. And before I drilled any holes, there was not substantial enough leakage in that box to get a reading. And I ran it for like 10 minutes to go, okay, it's going to equalize. It's going to become an even pressure. So I know that when I did the only test that I ever did that was unscientific on my garage floor at my last house, I couldn't get OSB to leak on a 4 foot by 4 foot by 4 foot box. That doesn't mean that all OSBs are created equally. I think most people would point at Zip and LP and say that those products are still OSB, but they're not the same as what we buy to walk on the job site. I mean, not anymore now how expensive it is. We may as well just buy carpet for outside at this point.
Yeah, or what I recall from this is going back 5 or 6, 7 years ago, was that some of the research was looking like it was specifically a problem with aspen-based which is only produced in the north and not even everywhere in the north. So it's what we can get get here locally, and so it's something about the way the fibers glue together versus southern yellow pine or Doug fir that are used for OSB elsewhere tend to just glue together more solidly. And yeah, for most projects it probably wouldn't matter, but when you're relying on that, well, and structurally it works just fine. So maybe it's a case of that there's no bad materials, there's just bad applications. Maybe just we shouldn't expect OSB to be a perfect air control layer, air barrier.
It just reinforces the need for testing. I mean, you can, if you're planning to tape your OSB seams and use that as your air barrier, if you test it and you've taped it and it's not working, theoretically, that would be a good time to add either, well, a number of different exterior products that would solve that for you. A fluid applied would be the very high-end, expensive. Let's shoot Proseco at it. That will solve everything. That's a great solution. And then on down the line, you can actually make Tyvek an air barrier if you don't put a bunch of holes in it, which is how you typically install Tyvek, is by putting lots and lots of holes in it. So there are other ways, but there was a specific question in the chat about non-zip exterior air sealing measures, air barriers. Instead of, I still like the idea of talking about air retarders. You know, we talk about vapor retarders. I think we should just talk about everything as an air retarder, and then there are various levels of that. And instead of talking about permeability only with vapor, we'll just go ahead and apply that across, and we can have lots of really super nerdy number conversations and address those levels. And then it's a whole new opportunity for bragging rights, people. Let's get in on it.
Well, I also want to bring up something that popped up in the chat box too, which is the blower door test and, you know, the ACH and your leakage rate isn't necessarily an accurate portrayal of what's happening, because it's so much more important for heat loss calculations if the holes in your ceiling are patched than the holes in your wall, because the holes in your walls are usually at the neutral pressure plane. So you're going to have more forced heat loss through the top and the bottom than you are through the walls. And so we're having this whole conversation about whether or not OSB is good, but if you're not using OSB on the ceiling, you've got some ceiling surface, you may still be way ahead of the game in, we use ACH. That's how we are testing it. It is important. It's great to know, but the number of holes in your ceiling versus the number of holes in your walls is way more important, right? So that sheet good that, you know, maybe if it's a cost issue, you use the zip system on the sheathing to create, on the ceiling to create an air barrier, or you do the continuous layer of sheetrock like Jake does or whatever. And that might have an even bigger impact on the actual performance of the house under natural conditions.
Well, I had this conversation with Peter Yost recently when I just called him out of the blue and said, I feel like the blower door doesn't mean anything. I feel like it's not natural leakage. It's not natural pressures on the house. And it's just a way for us to have a pissing match against each other, but it doesn't actually dictate where things are going to leak. And you know what Peter said? He said, yeah. And then he moved on to another topic, and I was like, dang it. I was hoping for some sort of wisdom that I could try to expand my knowledge with. But that's the point, is that the blower door is the only real metric that we have to be able to compare to each other. And you're right. It doesn't take into account that the sill plate and that vaulted ceiling are going to leak worse than the kitchen window.
But on the other hand, I'll argue, even if it doesn't have a specific, even if it's not specifically super accurate, before we had ACH numbers to compete with each other against, were we even worrying about where we were? Like it's, yeah. So like our house is tight. Like once we started learning to get that we should be getting tighter houses, like, okay, how do we get to 3 ACH 50? And that was a challenge. Then it was, how do you get to 1? And then it was like, holy cow, passive house is impossible. Like you just can't get to 0.6. And now we're like 0.2 and 0.1. It's just like, yes, a 0.1 ACH 50 house isn't that much better than a 1 ACH 50 house, but it's tighter. It's probably has some more attention to detail.
I think now that we have blower doors and we have those numbers and we can use them as it's a tool, right? And you can use the tool for blower door guided air sealing, right? So you can look for those leaks, especially Jake, when you're just doing it for your shell, you can identify those leaks. So you can notice if they're in the ceiling, you can pay more attention to those. So it is a tool. It is useful. And yeah, maybe the number is a little bit arbitrary for what you'd be using it for, especially if you end up sealing a whole bunch of neutral pressure plane areas, stuff in the wall system that's halfway between the top and the bottom. But it also really spurred the discussion about, like Mike said, ACH 50 and paying attention to that. But now we can really get people to stop saying that their houses need to breathe, because we have something to reference
I think they do.
No.
Still the
That's why Travis is
still
cheering.
the
I think houses do need to breathe.
They need to dry.
I think they need to breathe. They need to breathe mechanically on my terms, but they still need to breathe.
Okay.
People need to breathe, so they need to have a lung system, which means they need to have ventilation. But I think it was Christoph, the spiritual advisor of BS and Beer, who says we don't breathe through our skin, we breathe through our lungs. So our houses should do the same thing. We should breathe through our lungs, which is our ventilation systems.
Yep. So we're in agreement.
Yeah.
They do need to breathe.
We need to breathe. People need to breathe. Houses need to dry.
I saw in the comments somebody asked, what about returning and retesting houses? We have 3 new construction houses that we've retested more than a year later, and the numbers were negligibly different, just so you know. And I'm going to retest my house in the next couple months. And we have another project that's coming up on a 2-year anniversary that we're going to test for a 3rd time. So
Nice.
I think
got
that's
distracted because I was yelling at you in the chat box with all
I
caps
saw
and
you
then misspelling
semantics.
3 words. It's a disaster.
We want to have a semantics argument. What are you talking about? That's what makes this fun.
Nothing derails a productive discussion like a semantic argument.
You're ruining my fun, Travis.
That's not Gaelic. Okay, good.
Yes, I'm fluent in Gaelic. Try to keep up, people.
Back to Dietmar's comment about other exterior air barriers besides zip. I do a lot of double stud walls here. It's a cold climate, and we've done testing to show that even with everything being good, the sheathing does accumulate moisture in the late winter, early spring. It doesn't mean it's a bad system. It just means you need to plan for that. And so I've become uncomfortable using any OSB product with a double stud wall. I love zip when I have exterior insulation, which is another good approach. But with a double stud wall, I'm using CDX and taping the seams, and that's the primary air control layer. It does take a little bit of attention because where you have voids on the edge of the CDX, you need to fill those or caulk them or whatever. But just CDX opens up a little bit more when it gets wet. It's a good air control layer. That's what I do. And then you could also go over that with something like a self-adhered membrane, like Henry Blueskin VP100 or Sega Mayvest SA or one of those that sort of gives you a WRB and a perfect air barrier over pretty much any substrate. Do you guys use those self-adhered membranes at all, or use CDX on the exteriors?
Money.
Nope.
Money.
I take money to the side of the house.
For you, Mike,
Yeah,
have you had any instance of double stub walls that had zip on the outside that also had a problem?
We have moisture sensors in one, and it has slightly elevated. Actually, no, in 2, and they have slightly elevated readings in the late winter, early spring. On one of them, the sensors died, so we assumed it would probably settle down because we're sort of finishing up construction. Long story, but yeah, it's not horrible. It's just it's not. It's more moisture than on the interior, and so it's enough to just be a little bit nervous because I don't necessarily trust my skills to read a sensor or trust that the sensors are going to be dead accurate. So we know just basic physics says moisture is going to build up there. So it's not a bad thing. It's just deal with it. So cellulose with borate treatment is a good protector, but belt and suspenders also like to make sure the sheathing can dry easily. I really prefer board sheathing or no sheathing, but that's not always easy either.
So just to clarify, I want to make sure I'm not messing this up. there's elevated moisture levels in the cavity insulation because the zip is insufficiently vapor open. Am I understanding that correct?
No, well,
Jake knows where I'm going with this. So,
yes.
Okay.
I don't want to blame Zip. I think Zip is a great product.
No.
Or just
the application, like you said.
Yeah,
it just doesn't do the same thing
OSB,
as other materials.
OSB in general, not just Zip. OSB
Okay.
in general.
The plywood will also accumulate moisture from seeing
but it's
what
more
happens.
durable.
Right, it's more durable. Plywood can hold up to repeated wetting and drying better. From what I've seen and most of what I've read, there is some contention with that. And then just even high quality OSB, when you repeatedly wet it and dry it, it swells up. It doesn't fail and fall apart. It just sort of gets kind of spongy. And especially if you're relying on that as your WRB, once it starts getting spongy and the seams swell, I get nervous about that being a good. I mean, pretty much any assembly is going to be fine for 10 years. It's what are these buildings going to look like after 50 years of climate change and harsh conditions and everything else?
Yeah, 100%. I only brought it up because there's been some argument about vapor moving through zip in an assembly that I'm working on that I've been told is very risky. And so I'm curious how it doesn't allow vapor to move through in a wall, but in a roof it does. And so I just keep bringing it up and trying to understand it because I'm trying to wrap my head around it and do the right thing. That's all.
Yeah.
I wasn't trying to pin you down or blame you. I just wanted to make sure I understood.
We're technically talking about vapor movement, but it's an air barrier. It's a zip system and you have it on a ceiling. So where's the zip? Where's the insulation? I need more information, Travis.
Let's do that in another show. This is an air barrier show. Let's stay on topic. And I'd be happy to do that because I want to get it right on my build, but this show is not about my build.
Yeah, I mean, we can make the argument that a fantastic air barrier is a pretty darn good control layer for vapor too.
I would agree. I like that argument. I think I have relied on that argument a number of times, so I like that one a lot.
Or so on the project that our sensors failed, we had a conditioned attic, tight budget, high performance. So we looked at a bunch of methods, and we ended up sandwiching the rafters with zip on the interior and exterior. We have 7/16 zip on the interior as our vapor control layer because it's a class 2 vapor retarder. And it's painted, so it's a good vapor retard. It's a class code compliant vapor retarder on the interior. On the exterior, we have 5/8 zip sheathing as our exterior layer, airtight layer, air control layer, and then we strapped the exterior and roofed on the outside of that. So actually, we're using the same product zip as both our vapor retarder and a vapor open sheathing. So it's. Because moisture will work through, and once it gets a little bit damp, it'll dry through the material. I'm not sure if I would do it today, just because it's slightly risky, but it's yeah.
Does that answer your question, Travis? They do both.
Oh yeah, crystal clear. Now I know just what to do. No, let's revisit the air barrier conversation. There's a good question here about XPS as an air barrier, which I think is an easier one to answer because it's plastic faced. And if you can tape it well, most of us have seen movies where someone gets a plastic bag pulled over their head and held really tight, and then they aren't able to breathe and they die, which would make me think good air barrier plastic. So if we have a plastic coated XPS panel, the plastic is the air barrier if you tape to that very well. Also, I think closed cell foam doesn't allow air through it. So it's I would think that would be very effective as an air barrier. The problem with that usually comes in detailing it at the penetrations because Emily is desperate to say something. Please interrupt me.
I can't follow the chat box. You all know that. I am impossible, but I have the chat box up. And I actually think one of the questions related to that was whether or not the rigid insulation could be on the interior inside of the sheetrock. No, which is an additional question, because I think the way you're posing it is it's on the exterior, and depending on what climate zone you're in, on the exterior is okay. But we have gotten questions on whether or not you can use the XPS or something on the interior face of it. Like, what do you do? Like, it doesn't need to hang siding off of it. Like, what if we just used it on the inside and we had a continuous layer and we had foam on the inside?
It brings up a good point. First, if you can put that air barrier on the outside where it's easier to make it continuous and not have to go around studs, not have to seal around 24 interior outlets, just 3 exterior outlets. let's put it on the outside. It's way easier to buy in big pieces and detail big pieces connecting to other big pieces than it is to caulk every single stud to plate connection and then stud to OSB connect. Like, let's acknowledge that, yeah, there are a dozen ways to do this, but it is easier to put it on the outside or to put it up in large sheets at least. Whether or not XPS on the inside is a good idea, I mean, it has to be covered by something for fire rating, right? So at that point, why don't we just put it on the outside? When we put it on the outside, put some strapping on big screws and then mount our sheathing to that, or our side cladding to that, if that's your preferred method for an air barrier. Travis, were you laughing at my comment in the, okay.
Yes, the clarification that I was only referring to that in movies and not something I have.
He's only ever seen people have a bag over their head in movies.
Plastic bags. Yeah. Yeah. I prefer to do my killing the old-fashioned way, bare hands. I'm not really a plastic bag guy. These newfangled plastics aren't very friendly to the environment, Jake. Read the chat.
I don't know if you can kill him with a paper bag, Travis. That's not a very good air barrier.
No, it's an air retarder, Emily. We talked about this. No, I will answer the other point in the chat that, of course, XPS is terrible for the environment. We've established that. I wasn't advocating for its use. I was just answering a question that, yes, I believe that could be made to be an effective air barrier, as a plastic bag could, as a number of things could be. As long as they're continuous and go around all the sides, they can be made to be a good air barrier, which is why I always bitch about the doors on the house. Instead of complaining about the problems at the giant panels that are all sealed, I spend more time talking about good windows and not just the crappy box store door that is going to leak all the way around, all the time, every day, forever. And there's usually 4 of them on a house. So those are bad.
No, I was going to say, but in favor of the interior air barrier and sheetrock, I 100% agree with Jake. You have outlet boxes, you have light switches, you have all kinds of stuff, right? So that interferes with it. But we know sheetrock and compound is compatible, right? Do we worry about connecting our sheet goods on the exterior with things like tapes or membranes? You know, the same with the foam. The failure at the foam is going to be in between each sheet good, each panel, right? The transition between, okay, I got foam on the outside of my wall, but how do I tape that over the top of my wall to connect to my ceiling air barrier, right? So like, is the failure of sheet goods as an air barrier the connection points between them?
Yeah,
versus,
for sure.
Yeah,
it's not the nail holes,
the sheet itself. Yeah,
you know, and it's a combination of, we have to work with manufacturers that we believe when they tell us stuff, and then we have to determine for ourselves that our belief in that promise is accurate. So I don't know if you've seen Steve's 2 pieces of zip sheathing that he's had on his wood pile for 12 years now, and the tape's not peeling. I built a mock wall in 2014 with it, and mine's south facing. It's not protected by anything. It's up against a metal wall. It's taken some serious beating for heat and those sorts of things. And until about 19, it didn't really look like it had aged much. It had changed colors a little, but all the tape was still sticking. It's really starting to degrade now, but they don't make a claim that it's going to be exposed for 7 years, you know. So I'm not worried about
UV
that.
stable for 90 days, right?
Yeah, I
7
think
years
it's
is that big ass.
180. But the only, and I'm not looking for any more information out of it. The only reason it's still sitting there is it's been a while since we've had a dumpster at our shop. Like, that, it's not there because I'm still trying to glean something from it. But I do believe that I can believe in the promises that they make with their products. So that's why I trust it. And no, I don't think the panel leaks. I don't know if I also made a Build Show Network video where we found some overdriven fasteners on one of our projects, and we sprayed the outside with a garden hose, and I built a zip box that made it around those 2 studs on the inside. We taped to the inside, and then we depressurized for an hour at I think 100 pascals, and we couldn't get any water to penetrate the holes. They're not leaking. We're putting a rain screen on it. It's not being challenged anyway after we're done, but they're not leaking. If we're paying attention, we're not having problems. I regularly put drywall ceilings in without a roof on because we use the zip on the roof and we tape it. So. Mike Gurton has crappy box storehouses or doors in his house, by the way.
Yeah.
That's the only thing I can read right now.
I was interested in getting back to doors. I think we've covered can sheet goods be good air barriers? Yes. Done. So I'm moving on with other air.
Oh wait,
air controls.
Mike, before you go to doors, I have 2 houses that I took from above 5 ACH 50 in a remodel to below 3, and they both have a commodity grade OSB on the outside.
Yeah,
as Proseco or Stowe.
There it is.
Yes, it's a good substrate, huh?
It is. It's great for putting other things on top of that are better.
Yeah. And when it cost $8 a sheet, it was easy to justify.
Yeah.
Yep.
Yeah. So on doors, I mean, I think Travis is right. Like we can get passive house doors that seal like a bank vault, but most people aren't going to spend $2,500 for their entry door. If they are, they're going to want it to look a little fancier than your average passive house door. So yeah, what do you do to make them airtight? Mike Garten says his is reasonably airtight.
I find that if you want your door to not leak air, you have to be willing to use effort to close and latch it. It's kind of like your windows. If you have a window that you can just one finger slide down and it latches, that's probably not an airtight latch. And of course I did this because I'm in the Midwest, so we have double hung windows here. I know Jake's going, you mean this and this? I know, Jake, I know.
It's actually that.
I'm like, does it go up or is it the other direction? Is it tilting or is it turning?
Okay, smarty pants. My point is the same. For most of the windows in my market and most of the doors in my market, people don't like to make an effort. They are really persnickety about the level of effort that is required. And I have routinely had people ask me to adjust their door so that it will stay latched when they just lightly push it. Yeah, they want to be dainty in closing the door.
Yep.
I think that's fine. I'm happy to do what they want. It's their house. But I always say it's no longer sealing now. The way that I have it set up is so that when you close it, it has good positive pressure across the seal all the way around, because just touching isn't adequate at the lower corner where you have the little pad that kicks the thing out just a little bit and sets on the threshold. If you have good pressure there, you have light pressure everywhere else. You need to be able to close it and latch it with enough force that you've created that positive seal. Otherwise, you typically, especially in my market where we have 105 and we also have -3, we get those seasonal deflections, not just in the door. I thought it was just the door. Turns out it's the whole damn wall. The whole jamb will deflect seasonally. And it makes it very difficult to keep your client satisfied with the function and operation of their door and also have performance. So if you have a very stout client who is used to slamming their big, heavy truck doors, you don't have this conversation. But if you have more refined clients, they typically don't want to have to lean on the door to latch the deadbolt. And I don't blame them. It's their house. I want them to be happy. But that's why I probably do.
I have a remodel solution for you too, for the leaky box store door.
If it's higher aero building, you can.
This is the profile that they send you for the weather stripping around the door, right?
Yep.
You get the door that there's finished casework on the inside, there's finished casework on the outside. You're not remortising hinges and things like that. Like a half dozen times now, I've put a little backer rod
inside. Yep.
Inside that little, and that's plenty to make most of them seal well, but you're still asking your little lady client to put her shoulder into it.
Yeah, I can make it seal really tight, but then you have to try hard to latch it. That's all. And I don't want to readjust the latches to 6 positions and come back in May, and then come back again in August, and then come back again. Yeah. Now I'm just bitching. Sorry.
Can we pause real quick just to acknowledge that Mike Girton complimented me in the comments? That's all. We can go back to whatever you guys want to talk about now. Or if we want to talk about that, I'm willing to talk about that. Mike's comment about I did well.
So the door question is always really hard too, because that little old lady also has to be able to get out of the door at the end too. So when they're closed and they're latched really
maybe
tightly.
Not at the end.
What's that?
Maybe not at the end.
Maybe not at the end. Sorry. That was poor word phrasing right there. But that is an issue, going forward. But I also find that when you have a client and you do blower door testing with them and you walk around and you're kind of like, okay, we need to go around and we need to make sure that every window is closed and latched. All of a sudden, it's like almost like something clicks, in that. And so I think as we're doing more and we're educating more, they're thinking like, oh yeah, like maybe the window isn't.
I haven't
leaking.
shut that window for 6 months.
I need to latch that. I wonder if that is closed, which only really works. I had this whole discussion with Ecotrope, who is our energy modeling provider for HERS Ratership, about like, what do you do with that data and what happens with the next homeowner? Like, that's great for that first homeowner that we built for, but what happens with the next homeowner who doesn't know how the system works, doesn't know they need to lock and latch the windows, etc. So,
I imagine maybe it's easier to build airtight houses in bad neighborhoods where people get really worried about whether or not their windows are locked or the back door is locked at all times.
Well,
I'm picky enough that I have I have triple glazed windows. I'm also a contractor. My front door and back door are leftover Anderson patio doors that I ordered like 7 years ago that I kept in my shop so that I could use them on a house one day because they were like $3,500 worth of doors. They have the 3-point latch. My family thinks I'm ridiculous when I walk past it and I go, 3-point latch. Like, I want it to not leak air. I'm not locking the deadbolt. I know you're outside. I'm just, but that's the same as like most of parenting is walking around turning off lights, I guess.
Since it's the Mike Girton show too, though, tonight, he also made another valid point, which is, people will do it in fire prone areas and, like poor air quality areas, right? Because they'll notice inside, right? So apparently we just, you got to do it in bad neighborhoods where it's important to lock it, and you're going to do it in bad air quality areas where it's important to really seal that.
To have that control, right?
So we did talk about around the door, but we haven't talked about under the door. And I just threw a link in the chat for the only good product I've ever used for success at the bottom of an exterior door. It's the PIMCO drop down. And if you guys have used these, it is a game changer for that location because, of course, the exterior doors that most homes get have the 4 little fins on the bottom. And most of the time, the first one is already worn off before the build is complete, because the threshold didn't get adjusted quite right by the framer when he installed it. And then when the trim carpenter came in and was finishing things out, you're like, oh, yeah, adjust that door. It's rubbing a little bit. He just was like, oh, it's already torn here. And he just pulls it off like it's a tearaway bead on drywall. And so now you're down to 3. So a year in, you got the first 2 that are dead flat. And then the inside one that the cat got a hold of, it's gone too. And so at year 5, you now have nothing under the door. And it operates so easy. But that PIMCO thing, that thing is badass, man.
I was certain when you said you had a recommendation that it was going to be those 2 tubes of foam connected by the piece of fabric that you slid onto the end of the door.
We had one in my house that my grandma made that looked like a dragon. Did you have that? It's nice.
Yes.
No, my grandmother didn't do the same number of drugs your grandmother did.
Oh man, what about windows? Do you think double hungs are as bad as we're supposed to think they are? Do you think casements are really that great? Should we all be doing
I
tilt
know
turns?
that I've yet to find a double hung window made by a manufacturer that I think makes good windows.
Ooh,
wow.
Ouch.
Apparently we need to have Jake on for a window show. I think this goes back to the question that we had before, which is neutral pressure plane. Where are your windows located? How leaky are they? I mean, how old are we talking? If we're talking, weight and chain windows from the 1800s, those things leak everywhere, but at the same time, when you start talking windows and comfort levels and, sealing on them, casements aren't always the right answer because they open out. What if they get rained on? That's a bigger discussion. And I find that our biggest issue with the triple pane tilt and turns is people are concerned about what they're going to do for interior shades or whatever because they open in. Not realizing that I think most people for ventilation use them in the tilt function and you turn them when you want to wash them to clean them.
Or most of the time when you want the window open, you're not also closing the blind because that's going to stop the airflow and negate the fact that the window's open.
Right. So, as far as air infiltration, I mean, double hungs are always going to be the leakiest thing. The gaskets are poor. There are window manufacturers who haven't updated that in 30 years, even though there's, market proof that, so yeah.
There's more gasket too.
Right.
Like
more mating surfaces.
Same size window. Yeah. The same size window in a casement cuts out whatever that is, a quarter.
But if we're going to talk air leakage around windows, we should really talk about how the window manufacturers are making improvements on your existing homes. We seal around our windows better now than we used to. It's like 90% of it is not the window itself.
It's the install.
We're just better at installing them.
Well, before I knew what energy efficiency was, and before I was interested in high performance, when I was just trying to execute things from a good carpentry standpoint, there were probably 2 or 3 years early on when I bought the business where we did more than 250 sash replacements a year. And I not once foamed around the existing jam that we were leaving in place or pulled casing. So I was part of the problem for a long, long time. I used to cut the rope and let the weight drop in the wall and then use my hammer to flatten the pulley enough that I could get my sash replacement into the opening.
See, but you don't know till you know.
Contractor.
And now you know, and so now you don't do that anymore.
Yep, and that's why we don't do window replacements like that anymore too, because that method is the only method you can make money doing it.
Well, and now the latest that I've heard from Christine, and I don't know all the ins and outs of it, but it's actually better to not foam your windows and to use tape inside and outside. So you have give and take. I already don't seal the outside of the sill because if it leaks, I want it to drain outside. Do you guys think that fully foaming the windows is the way to go? Is this touchy subject? Oh, Travis looks nervous.
No. We've had this conversation a number of times, and so I'm anxious to hear what Jake will say today.
Okay.
Today.
I think it depends on your assembly. I think it depends on the exposure of the window. I know Ben Bogey will make an argument that one time he saw the foam wicking things back uphill. I'm not building on the coast, and I'm not building walls and windows that are really super high exposure, because most of the time I tend to work with a great architect or Steve, and it's easy for me to I'm reading the comments. He doesn't get away with. He also texts me, please call me, after he tried to call, and he's in the comments. He's trying to pretend like it's an emergency. I think that a face sealed window is wrong for most contractors and most install crews. And I know for a fact that a face sealed window can work if you're paying attention. We've done it more than once. I did it on my house. My windows are not high exposure. My windows are completely filled with foam on the inside all the way around. If I were installing flange windows, no, the bottom's open. I'm using a fibrous insulation or backer rod and sealant, and not worrying about that little bit of insulation around the window.
So,
it depends.
Emily has to drink.
Which Steve, sorry, I gotta take a drink. Which Steve said was a cop out, but that means that apparently Steve will answer all of your questions. Every time someone has a question about it.
Yeah.
No, what Jake said there is really important because the level of exposure should dictate your strategy. If you have windows with a nice, generous overhang that are protecting them from 90% of even wind-driven rain, face seal them and tape them. Even if they're not necessarily Schuco's high-performance magic gasket, best in the industry windows, even if they're leaky double hungs, I still think you're probably going to be safe 90% of the time in that application. We have a 3-story on one side, 2 above grade and 1 walkout, but it's still, that third story is above grade. So I'm calling it 3 stories on that face. And we used a different sealing strategy at the top. The windows that are up there are protected by the overhang, and we just face sealed them, and I feel very good about it. And we've had a lot of storms, and I didn't go back and foam the inside for many weeks. We had a nice long delay on our drywall, so I had a lot of opportunity to check it, and we've had no issues. Now, we could have issues down the road, and I could be coming back on the show to atone for my sins the way Jake is atoning for his previous sash weight pulley beating. But I think that there's a lot to be said for doing the right thing in the right place and not just saying, oh, blanket, no, this is absolutely the wrong way. I do think that my personal preferred method is always going to be the backer rod and sealant at the interior. And that's my air barrier. I don't really, obviously I want to not have water go into the assembly. So I'm still taping the outside to a point, but certainly leaving the bottom open is reasonable in that application. Most of the time, that's your lowest risk. But I do think that you can definitely get away with taping and face sealing a window in a low exposure area with extremely low risk.
I'll say that my house is now roughly a year old, and I had a conversation, someone that lives in my house that's in charge of me talked to me about going outside and washing off the windowsills because they don't get enough rain, that they're dusty and dirty. So if you have that problem, I think you can probably do a piss poor job of face sealing them and they'll still be okay.
Well, and I think it's 2 things, and Travis brought up a good point, which is the backer rod and the sealant is for the air infiltration, which is what was poor about the old windows, was why we went to foam in the first place. We used to just stuff fiberglass in there or have those open weight and chain pockets, just open air. And it was a bad idea. Like you said, in lower moisture climates, it's not a big deal. Here, though, it was a really interesting, we were building in the wintertime, and we had those fancy Schuco windows, right, Travis? I know, taboo, but we have them.
Not taboo. That's great product. I don't have anything against Schuco.
I know. And we taped them, but we had interior moisture. We needed to be running the dehumidifier because our drywaller was there. And where we saw moisture condensation was on the tape around the windows, because that was the worst part of our wall assembly. And now, granted, it was a very short period of time for what we were doing, which makes you think like, okay, in some climates, is tape enough? Do you need a little bit of insulation there? I mean, we could have stuffed fiberglass in, taped it. Maybe that would have helped, because then you've made it into a vacuum. But I think the important part there is, the air barrier around that is the most important part. That's where it leaks on a window. Even if you have the leakiest double hung, close it and lock it. Everyone, lock it. It's good. But then, how it's installed, the air barrier around it is where it leaks. But then again, we're back to the whole pressure plane thing. Is if that's a neutral pressure plane, it's still maybe not going to leak a whole lot.
Well, and I think most of the American manufacturers say no spray, no can foam around it, period. Mm-hmm. So then all of this doesn't matter. Can't use it either way.
I think that they're doing that so you don't deform their window and cause pressure that.
No, they're doing that so that you don't deform their window.
Right. Of course, I'm the one that's causing the problems in Jake's world. That's essentially always the solution, is to remove the poor installation by me. I wanted to take a second to just thank Jake. He was really kind to join us as a surprise guest tonight. And it was fortuitous that he did, since Chris was not able to make it after all. But I also know that Jake has been in Kansas City for the symposium the last few days, and he has a lot of obligations that he needs to get to. So I'm going to dismiss you, Jake. Thank you so much for joining us tonight. We'll continue the discussion without you, and it'll actually be factual and building science based from here on out.
Thank you guys. Thank you guys for having me.
Thanks, Jake.
We really appreciate it, Jake. Thanks for showing up.
Thanks again, buddy. We'll see you. I wasn't shutting down the show. I was just excusing Jake. He really did have some family obligations, so he was generous with his time to join us.
No, and for anybody on here, unfortunately, Chris couldn't make it. I think Mike posted in the chat. He had a family emergency. Hey, it happens every week, and the BS will go on because we've got plenty.
We
can talk about plenty of.
We can talk among ourselves. Should we invite a volunteer up to pick on, or just?
I vote Mike. No, I'm kidding.
Mike's in his pajamas. Leave the guy alone.
I know. He just spent 3 days in Kansas City. So for those of you who didn't go to the Midwest Building Science Symposium, you missed out. So I haven't done my hair.
He's got the curlers in.
So
we should still keep talking. And if there's someone that you think ought to be promoted, Mike, just clear it with them and get them on here. But we can keep the conversation rolling because air barrier is such a simple concept. Through that red line test, it seems so easy. And then you get down to actually having to manage the materials and all those transition points. And all of a sudden it gets as muddy and complicated as any other part of the building science world. So I think, we could talk about this stuff ad nauseum. We've already moved on to windows and doors. We talked a little bit at the beginning of the show about the top plate connection in terms of an exterior air barrier transitioning to the drywall at the interior. We did not talk much about foundation wall to wall connection, which my friend Etienne would probably remind me there are a lot of good solutions for. And, Jake and Steve's detail with the box store sill sealant, sill sealer gasket with a high performance like a Trimco acoustical sealant is a good way to then maintain that connection from your exterior sheathing. If it's or whatever your exterior air barrier is, you can maintain that continuity easily to a concrete foundation because you're not going to have air leakage of the concrete unless you're stronger with your lungs than Steve is, because he always talks about, well, if you think concrete's a poor air barrier, go ahead and put your lips on it and blow and let me know what you get. I'd like
to see that happen. I think there needs to be a video of that. I'm just saying. And I am absolutely, I think if there's someone in the chat box that wants a specific question answered, we are happy to do that, but we can also continue to just talk about this. And I like the discussion of connecting. We've talked about sheet goods being good air barriers, but now you just brought up this point, we moved to windows and doors, but we talked about connections. Like, how do we connect these things? Like, how do we make it continuous?
Yeah.
So
my favorite product I recommend all the time for a very tricky spot is how do you transition from foundation to sheathing, which is where I have my air control layer. I answer this on GBA like twice a week. Sega Fentrum tape. It's incredibly sticky. It's vapor open. It is the perfect material for that complicated situation. There are other things that'll work, but that's my go-to for that situation.
It literally sticks to everything. I think there are very few things that it doesn't stick to. But I would say in response to that is Sega also has some really good videos on how you're supposed to use the Fentrim tape, and that it is not a cheap it's not a cheap piece of material. So if you do it wrong, it's going to cost you. So I agree. It's absolutely, I specify it. We're trying to improve our details. So it's really specific on our blown up details, kind of where the tape goes, how you use it. It's not taped up and over like a sill gasket, and then how do you lap it and whatever. But, yeah, absolutely. I agree. That's a great foundation to wall sheathing.
Yes, and also like foundation or sub slab vapor barrier to foundation wall, which you have to do while the wall is still damp. Like there's not a lot that will really stick reliably there. Jake talked about acoustical sealant, which is this super sticky, permanently flexible, nasty, smelly, gross stuff with lots of chemical waste in it. um,
Telling you how you really feel about it, Mike.
Yeah,
it sounds very
no,
complimentary. It's a love affair, isn't it?
It does a good job, but my favorite alternative to that is Proclima. They changed the name, Proclima Contiga HF. It's this really pretty green color, permanently flexible, essentially, almost zero VOC. So it's kind of the opposite of acoustical sealant, and it does everything acoustical sealant can do. So I recommend that too. What do you guys like?
Go ahead, Emily.
I like everything that Mike likes because we work in the same place. And when I'm not sure, I ask Mike. Hashtag ask Mike. It's really, and that applies to Mike Girton too. So it's
but I don't know. I asked Mike Girton.
Moniker. So. Yeah, no, I definitely agree with that. And I just want to point out that we did do a sealants show, tapes versus sealants too. So people can always go back and kind of look into some of that, because that is the question, right? Like where's the failure point? How long do sealants last? We talked about this a little bit. And I think people kind of forget too, is that if you're using a house wrap or a fully adhered membrane, and that's your air barrier, and you're trying to use that, those only have a short window of time that they're meant to be exposed to the weather. So even though Jake's not actually doing a wing nut test in his backyard, he's doing a wing nut test, and he should put onto that. But like the product, manufacturers often publish some of that information, and it will continue to degrade afterwards, right? So we have to be careful with our tapes and sealants if we don't cover them in a certain amount of time, because our sheet goods are only as good as the things we connect them together with. And if we don't put siding on a house so we don't have to pay our taxes for an extra season, you may actually end up with air barrier and water barrier durability issues in your building as well. So not to be a buzzkill on the end of the night, but
that's all right. I think that's good transparency. Everybody's got their confessions. You're confessing for your market, not personally. You would never not side your house, Emily. You're a taxpayer through and through, obviously.
I like to admit all the things. I already told you my blower door number is like 8.5 ACH, and there is vinyl siding on my house. I'm saying that out loud.
That's an excellent rain screen. Good job.
Apparently, it might be able to. Well, I live on the coast, so maybe not. I think the siding might just be at the end of usable life. But I did learn a lot about deconstruction and taking that vinyl siding down, and that there are lots of people who will pay for that vinyl siding, even if it's only got 5 to 10 years more life for it. Sure. So let's, that's
There's a
whole
market
nother
for reused materials for sure.
Yeah, that's not an air barrier.
No.
Maybe we should not go down the deconstruction rabbit hole.
So since we talked about the fancy tapes and the fancy sealants that are not necessarily the cheapest or easiest to get for people in every market, right, I will point out that here in the Midwest, where a lot of that stuff hasn't caught on and there isn't a demand yet for it, although we're pushing that way and we're trying, we use the less fancy stuff in the less challenged areas. Like there's very little likelihood of whole house uplift that's going to separate I use Sashco Big Stretch with my sill gasket at that bottom of wall connection, and I kick my bottom plate out so that my zip can land on it, and then I make the tape transition wood to wood, so I'm not taping to concrete. And then I have a whole house holding that down. The uplift is pretty minimal. That sealant's not going to be challenged much at all. I've used that sealant in a number of places with great success. I really don't think there's a tremendous amount of uplift at the top plate to ceiling connection sufficient that we're going to really challenge that sealant joint there either. So I think that the forces that are challenging these joints need to be considered if we're going to have a serious conversation about how expensive and fancy to get with these things. I am more concerned, frankly, around a window, especially in a wall where the shear, you're not really addressing shear with a big panel. If you have a big window there, you have these little short sections to resist your shear of plywood or OSB or whatever your material is. And I think that's where you're going to see more movement. So that's really where I'm like, ooh, a fancy tape here that's got, a bonding surface that's almost 1.5 inches wide on each side of the joint. that's a fantastic place to reduce my risk. Whereas a sealant joint, where you're only talking about a 1/4 inch of adhesion on either side of the joint, and then you're relying on the elasticity, that's a little bit different. And you should just definitely make that decision for yourself. I have found that the fancy tapes are a pleasure to use. And so since we self-perform, it's not just about how much did the tape cost for how hard it is to use, how much does the tape cost for the purpose that's intended, and was it hard to get? It's like, do I have to put this up? Do I want to use something that I don't have to fix later? And do I want to feel the fleecy back as I pressure sensitive activate my adhesive? I'm just saying, a fleecy back's a nice back. That might be my parting thought for the day. Enjoy the pleasure of applying pressure to a fleece backed tape.
Well, I think that you brought up the round table, right? So, because we talked earlier, we talked about blower door testing, and we talked about OSB and sheetrock and how it's more important to seal the top and the bottom. But you brought up a really good point: is construction is all about cost effectiveness. So we need to be using these things where it's really critical and important. And when you're talking shear and the building might move a little bit more than you wanted it to, because instead of having a 4-foot panel, you've got a shorter section and it's going to move. It's really important to use it in those locations. You need a material that's specific for those locations and those movements. It's the same when you're thinking about your air barrier, you're doing your air barrier. If you don't tape a seam that's in the middle in the neutral pressure plane, you may never have an issue. But if you don't tape a seam that's in the attic, that's going to be a problem. If you don't, use tape versus sealant on that corner where you have shear and you have movement in your building, or I think it was you, and you were not promoting spray foam, but we were talking about spray foam and we were talking about drying out. And I think there are a lot of people who are meeting the ACH requirements of the code by using spray foam, which works really well on day one. But what happens when, like you said, the building moves, the spray foam now separates from the system, or, as we know, you're building with wood, it's wet on day one. Maybe you have convenience moisture from the slab. Maybe you have excess water in your building. It dries out. And now all of a sudden that spray foam, which was really good when you tested out because the building was still wet 2 years later, is not a very good air barrier anymore. And so I think, the air barrier question is really important. How do you do it? How do you do it in the right way, in the right places? And for cost effectiveness, how do we cut it down in other places? Where is it less critical? Where is it less important?
All good points.
Yeah, that was apparently to the next show because it's now 7:29. So it depends.
It depends. Yeah. And let's talk about spray foam. We had a very contentious in-person discussion on spray foam once with a spray foam rep. He and I get into it a little bit. So I think that could be fun if we.
Once it talks spray foam, we might have to get a pro. I don't know if there are pro. Yes, there are pro spray foam.
There are a lot of folks out there that are pro spray foam.
Yes, there are a lot of them. So yeah. So let's save that for a future show.
Yeah. And in all fairness, I had somebody talk to me about a project today, and for the durability of their building, it was best for them to use spray foam, which was not what I would have done if we were designing it from the beginning. It wasn't one of my projects. It's a contractor who's working on another one of my projects who's like, hey, I have this problem and I can't vent it. What should I do? And I'm like, well, it's already built now. So
I'm going to start using that. I like that a lot. That's already done now.
It's already built now.
Any other questions?
It's already built.
As I'm getting in my truck and rolling up the window, it's already built now.
It's already built now. Bye-bye.
That's the best way to end this.
All right. Thanks, everybody. Have a good night.
Yeah, thank you. Tear it down and start over.
All right. Thanks again, everyone.